The OWASP threat modeling is basically a structured approach to identify threats, but also coming up with good countermeasures. So this is a method that can be found on the OWASP website as well, next to the OWASP Top 10, OWASP cheat sheets. There's a lot of information. But threat modeling is a very specific one. It's basically something, an analysis that is ideally performed by a very senior cybersecurity engineer. And it's a combination of different things. So it's not really like a penetration test where it's a pure technical analysis with test cases. Here it is more an analytical approach, and yeah, looking at various facets of your system. So what are these facets? Starting with data flows. I mean, when you look at the OWASP website that describes the threat model, they're not starting with the data flows, but I think it's a good way to start with data flows, because ultimately what are you doing is protecting your data. And yes, access control is a major item, but if you follow the data, you will find also the access to it. So again, data flows, which means how you can do it in a simple way. Here, look at the opinion corner where I mentioned decompose the system, which means having a system design diagram in your hands is crucial. It definitely helps, because if you look at the application only, you may not know what modules does it have, how does it run, how is it installed. So you have to have some piece of documentation for this. System design diagram, system architecture diagram, different names for it. Data flow diagram, so be it. Important is what should be seen on it is how the system is positioned in the infrastructure, because from there you can start drawing data flows and say, here I start with the customer, for example, entering data on my website. The website goes through, let's say, a first reverse proxy, then my website, through the DMZ, then into the corporate network, and then the data goes into the database. From the database, there's a temporary file created, transferred to another server, because it's a different database type and they don't talk to each other or whatever the reason is. And then the data is split, because one goes for reporting, which is anonymized. The other one goes into the core system or the archive, or some other reporting system that is required for specific business transactions, for example, due to legal requirements. So that's how you simply can follow the data using the system diagram, because then you can see on which server or which cloud resource the data has been sitting, or it was in transit. And based on that, you can also circle around your assets, which is mostly data, of course, but it could be also, let's say, for some sensitive systems, even calculation logic. Sometimes that is also an asset, because it's so precious that people would pay money for it. It's not just only the data that is stored or generated, but it's also the logic that may be an asset. Therefore, you can circle around your assets and say which ones are critical. You can classify them. I mean, there's a whole other explanation on asset classification or information classification. Also important to see entry points and exit points. That can be from the user point of view, but you can also relate it to your data. Where's the data entered? Where does the user go in? Where does the data leave the system and go somewhere else? And that is important to have these things marked, because obviously this is where attackers can go in, and they're not using always the entry points, of course. They also use the exit points to enter. So therefore, you got to be very careful to document these properly, so that you know which server has this entry exit point that you then have to protect thoroughly, and maybe set up some additional logging monitoring there. But yeah, let's not go too much into the implementation of measures yet. So let's look at the next one, trust levels. This is something that you can also indicate with nice dotted lines in your system design diagram to say where do I have a trust boundary. So that means I need an authorized communication between these. And here it is, of course, will be critical because from a developer's point of view, they would like to have a smooth transition or smooth transport of data between the system components. But from a security point of view, if you don't draw that many lines into your chart, then you realize that it was probably not enough. Especially when people talk about zero trust approach and you have only one single trust line between the internet and yourself, that is definitely too little. And external dependencies, that's usually interfaces with other partners, other systems that you may not be able to fully assess during that OWASP threat modeling. So you have to put a risk factor on that and say, this is where I'm dependent on. If I don't get that data, then my system doesn't work. Or if I can't send my data, then I have a business restriction here. But can be also just purely technical dependencies. Let's say you're sharing infrastructure with another application or something like that. So anything external dependency that you can consider for you as a risk factor. So as mentioned before, determining the threats is one thing. So when you run through this detailed decomposed system, analyze each facet of these 6 points just mentioned, you can also put a source code review on top because that ultimately will show you what are these things. I mean, you will see, for example, the calculation logic asset. Yeah, you will see the data storage reference. You will also see how the data is passed from application module to application module. So source code review is definitely a great approach to complement this analysis. But ultimately, then, when you have the threats and the risks and the vulnerabilities and the weaknesses, you may have to come up with countermeasures. And again, countermeasures not just out of the blue, but try to make them executable, which you can then decide, because if you have the full system design in front of you, including the source code, you can really bring up good executable countermeasures and not something holistic where the DevOps team has then to scratch their head for days and try to figure out how to make this work and may compromise something else by doing the wrong fix here. Yeah. So therefore, important to have a clear countermeasure catalog for each of the threats, and it may lead even to a total redesign. So don't be afraid to, I mean, instead of having 100 countermeasures, which are also cost-wise breaking the business case, if you have to refactor the system and you have to fully redesign the core of it, sometimes that's the thing to go, especially when you have a certain foresight component to your review and say, well, there's a dependency here on a certain technology. What happens if this technology is not supported? What happens if there's a zero-day vulnerability on this technology? How would I resolve that problem then? Yeah, because implementing countermeasures now just to, let's say, mute the symptoms of a certain security issue may not bring you far. And so therefore, redrawing a system design diagram, not trying to fix it. I mean, it's like, just see it like you're reviewing the architecture of a house. You want to remove some walls to make big space, but then the static structure will not help. Or you want to try to protect a certain area or enhance a certain part of the house, and then again the static doesn't work. You may have to knock down the whole house, because otherwise all the supporting structures you want to build later are for the bin, and they're creating other problems along the way. So therefore, yeah, very good analysis. Has to be done ideally in a graphical visual way to really bring the point across and especially share it with stakeholders afterwards.